All right, everybody. We're gonna break this lesson up into two parts because it's so lengthy. So this is part one of the video, and we are getting into rational and irrational numbers. So fill in the diagram with the names and sets of numbers below. Write in a few examples of each set. So we're going to talk about these numbers first before we fill in the diagram below. So counting numbers. Okay, counting numbers are your natural numbers. Okay, 1, 2, 3, 4, 5, 6, and so on. All right, they're your natural counting numbers. We never start counting with zero, ever, ever, ever. So those are, those are zero does not fall in those numbers. All right, so this is your smallest set of real numbers is your natural numbers. Okay. The next one is the whole numbers. The whole numbers is pretty much the natural numbers with zero. So your counting numbers plus zero. So now you include 0, 1, 2, 3, 4, 5, 6, and so on. All right. So that's the biggest difference going from natural to whole. Zero's in there. All right. Integers. Integers contain both natural numbers and whole numbers. They have 0, 1, 2, 3, 4, and so on. But they also contain negative numbers. So along with 0, 1, 2, 3, 4, 5, 6, they go to negative 1, negative 2, negative 3, negative 4, negative 5. Notice how there's no decimals. Okay? All right, so that's the next biggest size. Now, all three of these sets of numbers fall under rational numbers. Okay, these are all subsets of rational numbers. Rational numbers, okay? And by the way, at any point in time, if you need to pause this video to write this stuff down, please go ahead and do so. So rational numbers are any numbers that can be written as fractions, all right? So whole numbers can be written as fractions, right? 5 over 1, 4 over 2, and so on. And these decimals are either repeating, okay, or terminating. So repeating and terminating decimals fall under the rational numbers category. 1/2 is 0.5. That's a terminating decimal. That's a rational number. Decimals that stop, or repeating decimals like 1/3, 0.3 repeating. That's a repeating decimal. All right. So all those numbers up above, integers, whole numbers, natural numbers, all fall into the big subset of rational numbers. By themselves are irrational numbers. Now again, those are numbers that can be written as a fraction, which means they can be as a decimal. And those decimals are non-terminating, which means they never end, and they don't repeat. There's no repeating pattern. So they go on and on and on forever, okay? And they don't end. Like you can literally write till your arm falls off. All right? So the most famous irrational number is pi, okay? Other examples of irrational numbers are any non-perfect square. Square root of 17, square root of 20, anything that doesn't come, that the root of that perfect square isn't a whole number, okay? Those are irrational numbers. So if we go down to our diagram here, in the very middle box here, the inside, the smallest box is whole numbers. And really technically inside of that, you can really even have another small box for natural numbers. Because again, they're 1, 2, 3, and so on. Okay, whole numbers have the 0 in it. Okay, all right. And then whole numbers then branch out into part of what we call integers, which have not only 0, 1, 2, 3, 4, but the negative numbers. And again, those whole three sets of numbers fall under the set of rational numbers. Okay, and again, you can have decimals, positive or negative. You can have fractions. You can have repeating decimals like 0.3 repeating. Okay, lots of different things. So as long as they fall under that set, they're a rational number. All right, the other side is the irrational numbers. Again, those are pi, non-perfect squares. Okay, so those are any square root that are not perfect squares. So anything that doesn't have a whole number square root can be a irrational number because they don't repeat and they don't terminate. All right, so this is a very important piece as we branch into this whole, lesson over 4.1, 4.2, and 4.3. So this is something that is very important that you're going to have to get down and know. All right, so this is something that's going to take some work to study. All right, so we're moving on. Okay, so the very first part we're going to focus on is rational numbers. Does every rational number have a decimal equivalent? So we're going to use long division on a separate sheet of paper to divide the numerator by the denominator I just want to make sure we're still recording here. Yep, good to go. All right, write the decimal equivalent in the space provided. Don't round. And then we're going to use the symbol for repeating decimal as shown in the example. You can see the line over the 6 here. That means that 6 repeats forever and ever and ever and ever. So I'm going to add a page here and just show you a basic one. Okay. So if I take the 1/3, we're taking 3 and dividing it by 1. Okay. So we're going to take 1 and go into 3. So the 3 is our divisor. All right. 1's our quotient. Or 1's what we're dividing. So 3 can't go into 1. Okay. You remember this from years ago, right? I told you if your elementary teacher told you it was going to come back and bite you, well, he or she was right. So because there's no 0 here, okay, we bring that down. We're going to bring down the 0 to make 10. So 3 can go into 10 3 times, leaving you 9. Bringing down the 0 again. 3 can go into 10 3 times, leaving me 9. And we have this repeating pattern of 3's, no matter what. So that means that this is repeating. All right. So you're going to do that for each of these. So if I go over here, all right, if I go over here, we're going to hit 1/3. It's 0.3 repeating. And since it's a repeating decimal, we're going to write it down here in part B. So you're going to pause the video and work for about 10 minutes or so, or if you're doing this at your leisure, until you can finish. So you're going to take all these denominators, have it divided into the numerator, and see if you can solve these and what you come up with. And then we'll come back and see how you did. So go ahead and pause the video. All right. So now that we're back, all right, I'm going to go through, I'm going to show these answers. Well, 1/2 is 0.5. That's a terminating decimal. So we can write 1/2 right there. Okay. 1/4 is 0.25. That's a terminating decimal. All right. 1/5 is 0.2. So that's a terminating decimal. So 0.25 terminates at the thousandth spot, and 1/2 and 1/5 terminate at the tenths spot. All right. 1/7. This is a doozy. Okay. This didn't repeat till you got to the 7th decimal place and it started to work itself over. So there's a line over 6 digits. 1, 4, 2, 8, 5, 7. All right. That is obviously a repeating decimal. So this is 1/7 right here. All right. 1/8 is 0.125. That terminates at the thousandth spot. So 1/8 is there. All right. 1/9 is 0.1 repeating. So that goes there. And 1/10 is 0.1. All right. So we're going to write that in here. All right. Now again, you should have done these by longhand. You shouldn't have done them with a calculator. So now what we're going to do is we're going to go down here to the next part because we're going to compare some data here. So now for this one, you can use a calculator. So you're going to take 9, hit the divide sign, and 2, and you're going to come up with some decimals, and you're going to go all the way across and fill these in. Now notice you got a few more numbers in here than you did on the table up above. So that's fine. So go ahead and pause this video, and then we're going to reveal these numbers and see where they go, and we're going to do some comparing. So go ahead and do so right now. Pause the video. Okay, so when we come back here, we got 9/2, right? 9/2 is 4.5. 2/3 is 0.6 repeating. 3/4 is 0.75. 2/5, 0.4. 5/6, 0.8, and then the 3 of it is repeating. So the 8 doesn't repeat. It's 0.833333333. That's why the line is only over the 3. Notice that 2/7 is double the size of 1/7. Notice that all the digits are double the size of the previous one. All right. So 0.285714, and that repeats every 6 digits again. 3/8 is 0.375. 4/9 is 0.4 repeating. 7/10 is 0.07. 5/12 is 0.41, and then the 6 repeats. And then 7/15 is 0.4, and the 6 repeats. So if we go ahead and fill these in, the terminating decimals are 9/2, 3/4, make a better 9 there, 2/5, 3/8, and 7/10. And the repeating decimals are 2/3, 5/6, 2/7, 4/9, 5/12, and 7/15. All right. So now that Um, now that we got those done, we're going to do a little comparing. So if we go down here to the bottom, take a look at the fractions with the denominators of blank that will terminate. So look at the two bubbles for in D and in B. And look at the denominators and see which ones are terminating. If you look, all those denominators are the same. 2, 4, 5, 8, and 10 all terminate. Okay? And there's a reason for that. The reason they all terminate is because all of these numbers can go evenly into the base 10 number system. Okay? And what the base 10 number system is this. Okay? So like 10 to the first power, which is 10. 10 to the second power, which is 10 times 10. 10 to the third power. So we're adding a 0 every time. Right? Those are your place value numbers. So all these numbers, okay, and it keeps on going. All those numbers up above will go into one of those numbers or bigger. That's why those decimals terminate. If you noticed up above here, right, we said that 0.4 terminated at the tenths. There's 10 to the first power. 0.75 terminated at the hundredths. That's the hundredths power. 0.375 was the thousandths. Okay, so that's why it does that. So now take a look at the repeating decimals. The repeating decimals are 3, 6, 7, 9, 12, and 15. Up above, 3, 6, 7, and 9 because we didn't have as many numbers as below. So if we put all those numbers in that we're repeating, the reason they will repeat is because these numbers do not go evenly into the base 10 number system. Try putting in those numbers into 10, 100, 1,000, 10,000, 100,000, and so on. They will not go in, which is why those guys at some point repeat. Okay? So that is why. So does every rational number have a decimal equivalent? Yeah, pretty much. All right. All right, so we are going to move on to the next page. All right. And actually, I'll tell you what, right here, we're going to stop because I told you we're going to make this into 2 parts. So this will be the end of the first part, which covers the first 2 pages of the note. So we're going to stop and pause here and play this video, and then we're going to go into part 2 here in just a minute. So here's part 1.